Hello everybody, and today we're going to talk about IXL T5, the one that you're going to be looking at the volume of prisms and cylinders. So T5, volume of prisms and cylinders. Alright, so let's start by just talking about these shapes. I'm going to start with the cylinder. The cylinder is actually super easy. I'm going to do my best to draw it on here, but a cylinder is just if we take a circle and take the same exact circle and then connect them with straight lines that you can pretend those are straight lines because those didn't come out super nice. There. Close enough. We would call that a cylinder, right? So think of like a cup, a soda can, a can of like vegetables, right? Anything that's like in that circular shape, it's got the same circle on the top and on the bottom, and then it's got a length connecting that. So the way that we find the area, or sorry, the volume of this figure is we use the formula volume equals big B times H. Now, what we want to be careful here is this one's a capital B. That means that capital B has to represent the area of the base. So you're not just plugging in one number for big B. Big B, you're solving for it and then plugging in some sort of a formula to it. So in this case, I would look at the base. Now, the base is always going to be the two congruent shapes on either end. So if you look at either end of this, whatever the congruent shape is, that's the base of the figure. So in this case, you can see that there's a circle on the bottom and a circle on the top. That's my two congruent shapes on opposite sides. So in order to figure out what big B in this problem is, we have to find the area of a circle. So I'm going to take big B and solve that. So the area of a circle, we learned, is pi r squared. So if I'm going to find the area of my circle, I'm going to figure out what the radius is and plug it in and calculate what this is. Once I know what number that is, then I'm going to plug that in to capital big B. The height represents the height of the cylinder. Cylinders are a little bit easier. It gets a little bit confusing in other shapes, but the height should always be however far apart the two bases are. So that would represent the height. The reason I say the two base distances is because in our heads we start to think, oh, base must mean bottom, height must mean going up, and that's not always true. I could draw this cylinder. I can't draw a cylinder. You're kidding me. There's a cylinder. I could draw a cylinder like this, and we might say, oh, now the bottom is here. That doesn't change anything. I would still refer to the two circles that are on opposite sides. Those are still the bases, and I would still call the height of this cylinder the distance between those two bases. So that's never going to change. So keep that in mind. The height is the length between the two bases. Never changes. Cylinders, like I said, are a little bit easier because you always have a circle. They always look the same. Prisms get a little bit more difficult. A prism is whenever two bases are connected by, that's not a Y, by rectangle, or we'll say rectangular faces. The faces are going to be the outside parts. So what that's going to mean is, for example, if I put a rectangle on this side and a rectangle on this side, I wanted those two rectangles to be the same. Let's make them look the same. Come on, Mr. Knock. There we go. That's closer. If I connected those two rectangles with a bunch of faces, I could make this three-dimensional rectangle. And we would refer to this as a rectangular prism. The rectangle being this part up front and this part in the back. Those are my two bases. And the height between the two rectangles would be this length right here. And we can see that the four sides, the four white sides, we would refer to those again as the faces of the figure. We also will see things like a triangular prism. So for example, if I have this triangle and the same triangle in the back, and I connect that together, you can see all three of the outside faces are rectangles, meaning it's a prism, but the bases are these triangles right here. So again, what that means is the height is not the height of this triangle. This triangle is going to have a height, and we're going to use that to find big B. But the height of the prism is the length between the two bases. So we can see these in any variety of form. You might see like trapezoidal prisms, where maybe we draw two trapezoids and connect them. I did a terrible job on that one. Something like that, though. It would look something similar to that. So a trapezoidal prism, we might see a cube, right? Which we might refer to as a square prism, but it's just a cube. So you might see a cube. Those are typically the ones that you would expect to see. So again, keep in mind the bases are going to be the two congruent shapes. The faces are always going to be rectangles. So what I'm going to do is we're going to take a look at these examples that come directly from the IXL to kind of help you prep yourself for the IXL and what to expect. So in this first one, it says, what is the volume of the cylinder using pi is approximately 3.14 to find our answer? Make sure we round to the nearest hundredth. Remember, IXL will mark them wrong if you do not round to the correct thing. So in this case, the first thing I'm going to say is use my big B times H formula. Volume equals big B times H. Just like with before, we're going to replace big B with whatever the base is. In this case, I expect my base to be a circle. There's a circle on top and a circle on the bottom. So big B is a circle, meaning we have to use the area of a circle, which is pi r squared. If I take a look here, it looks like the 8 goes all the way across. The 8 is the diameter of this thing, right? So the whole thing has a diameter of 8. And we know that then the radius has to be half of that. So the radius of this problem would be 4. So I'm going to solve that. Big B equals pi 4 squared. I'm going to go ahead and pull up a calculator. Let me go ahead and type this in here and get one up on the screen. Shoop, there's my calculator. So we are going to figure out what 4 times 4 for our 4 squared is, and that's going to give us 16. And then it said use 3.14 for pi, so we'll use 3.14 for pi, and I get 50.24. So I can see that in this problem, big B equals 50.24. Again, though, that's not the end of this problem. That's just step 1. In order to solve this, we're now going to take big B, which we know is 50.24, and multiply it by the height, which is the distance between the two circles. In this problem, you can see the distance between the top circle and the bottom circle is 3 millimeters. So I'm going to multiply this by 3. Bring my calculator right back on over here. So we're going to take this 50.24 and multiply it by 3. And when I do, I get 150.72. So I can put for my volume 150.72 millimeters. And since we're talking volume, now we're going units cubed. It's how many cubes can fit in there. So volume equals 150.72 millimeters cubed. In this next figure, it looks like I have a cube shape. So for this cube shape, again, you're going to use the same formula. Volume equals big B times H. And so with cubes, though, it's kind of easy. You can focus on really any spot because there's a bunch of rectangles. I'm going to make this rectangle on the side my focus. That's going to be my base. So let's focus on that as the base. If that's my base, I'm going to use the big B for a square formula. Well, we talked about how the area of a square is just the base times the height. So looking at the square that I darkened, the base is 10 and the height is 10. So big B is going to equal 10 times 10, which is just 100. So coming back into my formula now, take big B and multiply it by the height. The big B was the 100 we just found. The height is the distance between the one square base and the other square base. Since I made the base on the front the square, then the base on the back is also the other base, or the square on the back is also the other base. So the distance between those is this 10 right here on the side. So 100 times 10, and I end up getting 1,000, and it's yards cubed. All right, taking a look at this next one right here. Let's go ahead and make the base again this front part. I like just kind of make it the part that's up front so I can see it easily. So I can see that in this case the base happens to be a square. So base, not square, sorry, rectangle. So I have a rectangle, which again, rectangles we know are the formula base times height. Again, notice that there's a capital B and lowercase b. Lowercase b is going to be the base of that rectangle, which I can see is 3. And h is the height of the rectangle, which is 16. Multiplying that together, I'm going to get 48. And now we can use our big B times h formula. Volume equals big B, which we said was 48, times the distance. That's supposed to be a 4. I just made that worse. 48. There we go. And we're going to multiply it by the length between the front base and the back base. So you can see this 3 by 16 rectangle is matched on the back, and there is 9 yards between them. So 9 is going to be my number that goes here. That one's going to need a calculator for us to figure out. So I've got 48 times 9. I get 432, and we were talking yards. So this is 432 yards cubed. All right, we got one more on here, and that is the triangular prism. And this seems to be the one that most people make mistakes on. And I think it's because you have to start with a specific spot. You can't just pick anywhere like you could with the rectangle and the square. We have to start with this base right here on the front. So I've got this base right here. And we can see that the base of that shape is 12, and the height of that shape is 12 as well. But if you rush into this and forget that you're talking here about a triangle, you might end up using the wrong formula. So this is a triangle. We know the formula for the area of a triangle is base times height divided by 2, or 1/2 base times height. Well, in this case, the base is 12, and the height of that triangle is 12. So 12 times 12 divided by 2 is going to give us 72. And now we can plug that into our normal formula. Big B times h, volume equals big B times h. In this case, we now know that big B is 72. And h is the distance between the two triangles. So from triangle 1 to the triangle 2 on the back, there is a 15 centimeter gap. So we're going to do times 15. Let's take a look and see what we're going to get here. Oop, I'm seeing that my face is cutting that off. There we go. So 72 times 15, 72 times 15. I do that, I get 1,080. So I know that this volume is 1,080 centimeters cubed. Again, I cut off the units, just know it's centimeters cubed here. There we go. Ha! All right, jumping into these next couple of examples. These ones have us going backwards. It says the volume of a cylinder is 12,308.8 cubic feet. What is the radius if we use pi is approximately 3.14 and round our answer to the nearest hundredths? So we're going to want to think of these formulas as their whole formulas. So I'm going to take this volume equals big B times h. Now we know because this is a cylinder, big B is the area of the circle. So I could just shortcut this and take big B out and put pi r squared times the height in. That might make it a little bit easier for us to figure out what's going on. And then we're going to plug in the things we know. Well, I know that the height of this is 20 feet. I also know that the volume is 12,308.8 feet. So let's plug that in. For volume, I'm going to put in 12,308.8 equals. Pi, we know we're going to use 3.14. R, we don't know R, so we got r squared. And then times the height, which we just said was 20. Well, if I'm going backwards here then, I'm going to want to divide both sides by 3.14 and divide both sides by 20. So I'm going to take this 12,000 and first divide it by 3.14, then divide it by 20 so that I can cancel those two things. So let's take a look and see what that looks like. So take 12,308.8. We're going to start by dividing it by 3.14. And when I hit equals, I get 3,920. We're going to divide that again, this time by 20, and I get 196. So this whole thing here simplifies into 196. Over on this side, with these two things canceling, I'm left with r squared. Well, ultimately, I know then to get from r squared to just r, I'm going to have to square root both sides. Taking the square root of 196, I get 14. So I can see now that the radius here is 14. In this one here, they asked me to find the volume of this cube. Well, the thing is, we know that if you take u times u times u, you get u cubed. So u cubed is going to equal 4,096. Well, that's really easy to solve then, because to undo that, you're just going to take the cube root of both sides. So the cube root cancels here, and you just get u equals. And we got to figure out what the cube root of 4096 is. Let's see. The easiest way to do that on your calculator is you're going to type in your 4096. And then you probably have a button that has like x and then a square root. There's a y right there. I don't have one on here. But I'm going to raise it to the 1/3 power because it means the same thing. So 1/3 is 0.3 repeating. So when I put that in, I get 15.99999. So I can approximately estimate that that is 16. And we were talking about millimeters for our units. I forgot to put units on the other one. That one was feet. You may want to put feet right there. All right, scrolling on down, a couple more examples here. In this one, you can see we have a volume of a triangular prism is 50,439 cubic inches. What is the value of C? So again, we're going to take our big B times H formula. But where big B is, I want to plug in the area of that triangle. So I'm going to have base times height divided by 2 times that by... This kind of gets a little bit weird because we're going to times it by the height. So what we need to keep track of is which height is which. This height is the height of the triangle, so that's going to be that 86. This height is the height of the prism. That's going to be the distance between the two triangles, which is the 23. So keep those kind of separate in your mind of which one you're doing and when you're doing it and why. So I'm going to have base, the base, which is C. I'll just call it base for now. We can see the base is C, times the height of the triangle, which is 86, divided by 2, times the height between the two triangles, which is 23. And if I equal that, I'm going to end up with 439. So what I know I'm going to need to do is I'm going to need to start by dividing by this 23, multiplying it by 2, and then all I have left is just to divide by 86. So it's just a matter of dividing and multiplying things. So again, divide by 23, divide by 23, that's going to cancel. Then to get rid of this 2, we multiply by 2, that cancels. So we're going to multiply this whole thing by 2. And then the last step is we're going to have 86 times B right here. I don't know why my B looks so ugly. There we go. 86 times B. So ultimately, I'm going to have to take that whole thing and divide it by 86. And that is going to get me to my right spot. Sorry, I clicked off that. All right, so let's take a look what's going to happen then. Take 50,439. We are going to start by dividing that by 23. Excuse me. Then multiplying it by 2. And again, now I get that 4,386 equals B times 86. So if I want to figure out what 86 or what B is, I got to get rid of the 86 by dividing it. And when I do, I get 51. So I can see that this length across the bottom, which we called C, is, what did we just say? 51. In this last one like this, we have a cube and they ask us to go backwards, or a rectangular prism and they ask us to go backwards. So I can see that the easiest thing I could do here is acknowledge that this is the base, because I got both the numbers. So here's my base, which means z will be the height between the two bases. So when I go in and start setting this up, I'm going to have, nope, I didn't click on the pen. I'm going to have big B times H for volume equals, where we know that big B is the area of this rectangle. So that's just base times height. So it's base times height times the prism height. Again, keep those H's as separate ideas. So my base of my rectangle is 7.8, and the height of that rectangle is 5.3. And we're multiplying it by this height, which is z. We don't know what it is, so I'll put the z here so we can keep kind of up with it. So we're going to first figure out what that 7.8 times that 5.3 is going to give us. So 7.8 times 5.3, we get 41.34. So this is 41.34 times z. I forgot to put this in here, but we know what the volume equals from our directions. The volume is 305.916. 305.916. So now, if I'm going to solve this the rest of the way, we're just going to divide the 41.34 to both sides. And let's see what I get. I don't know why I just cleared that. 305.916 divided by 41.34. And I get 7.4. So we now know that z is equal to 7.4. All right, the last one you might expect to see tomorrow is one where they give it to you in words. They're not that complicated. You just got to make sure you draw the picture and understand what you're doing. So in this one, it says we have a cylinder. So we know that if we're drawing our cylinder, we draw a circle on top, come straight down, draw a circle on the bottom, make sure it looks nicer than mine. It says the cylinder has a height of 10 yards. So my height is going straight up and down. The radius is 5.4. So from here to here, 5.4. And it says, what is the volume using pi estimating at 3.14? So we know that for our volume of our cylinders, we're going to use that area, or sorry, not area, volume equals big B, which is pi r squared, times the height. Since we know the radius is 10.4, we're just going to, or sorry, 5.4, we're going to plug in our 5.4 squared here. And then times it by the height of the cylinder, which is 10. Bring in this calculator. So we got 5.4 times 5.4. That's going to give me 29.16. Times that by 10, I get 291.6. Times that by our estimate for pi, which is 3.14, and we're going to get 915.624. It does say round to the hundredths, so we know that when I go to round this, I can drop 915 points. Sorry, mad multitasking. We don't have to keep that number at the end, right? That 4 at the end, because it's going to round down. 62 is going to round down and stay 62. So I'm going to stop right there. My units are yards, so I'll put yards cubed. And that would be the solution we are going for. So hopefully that helps you get along with that IXL. I picked some of every example, so go back to this, reference it, and let me know if you need any help. Best of luck, everybody. Bye.